So question 5 says solve the equation by the method of your choice. Notice how again this is a second degree equation. This is a squared. So we know that we have to use quadratic strategies. This is not linear. Completing the square would be fine, but because notice how the quadratic term and linear term are on both sides, but I have to divide by 3. When I divide by 3, I'm going to get like this 2/3 and this 5/3. That's going to start creating fractions. I may not want to deal with fractions. So the other strategies is to set it equal to 0. So I'm going to bring this as 3x squared plus 2x minus 5 is equal to 0. Now, the question is it factorable? Now, if it's factorable, notice how since there's a coefficient in front of x squared, I have to multiply the 3 times the negative 5 and get negative 15. And then I have to add up to get a 2. Oops, don't need a plus 2 there, just simply a positive 2 would be just a 2. So are there factors of a negative 15 that give me a 2? Well, I know there's this 3 times this 5 that gives me 15. And to get a negative, one of them's got to be negative, but to get a positive, the small number is going to have to be negative. So what I'm picking up on is this negative 3 and this 5 are going to give me this factors of this factors of negative 15 that add up to 2. So this tells me that I can go ahead and use 4 squared as a strategy. Since it passed that test, we can kind of move on and do 4 squared. So with this strategy, the quadratic term goes in the top left. The constant goes in the bottom right. Now, these become the coefficients of the linear term. So this 2x gets broken apart into this negative 3x and this 5x. So that 5x and negative 3x represents this 2x. So when I do 4 square, I have to identify a common factor across here. It looks like we're seeing a 3 and an x because they both have a 3 in them and they both have an x in them. So what I can do now is figure out, well, what goes up here? Well, what times x is 3x? So if we took a 3 and an x out, that leaves me an x. What times 3x gives me a negative 3x? Looks like we brought everything out but the negative, which means we really need a negative 1 there. Negative 1 times 3x does give me this negative 3x. Now, kind of cheating a little bit, what I can do is ask myself, what times x is 5x? It looks like we're just missing a 5 there. 5 times x is 5x. And does 5 times negative 1 give me negative 5? Yeah. So this tells me this problem actually is factorable. So my choice would be then just to say 3x plus 5 times then x minus 1. So these edges become my factors. And then I just set each one of these factors equal to 0. And I'm going to get 3x equals negative 5, x equals then negative 5/3. And then x would equal 1. So that would be my two solutions. So x would equal negative 5/3, also 1. So it does have two solutions. So that would be the method of my choice.